Good morning, agents. My name is Alejandro Valdez, and I've been tasked with the mission of explaining to you arrays and pointers and what things they have in common, and in which things they differ, while also showing you a couple of examples. So, this is a very serious topic that hopefully will let you learn and become a better agent so that you can have a better performance in your missions. However, we can have a little fun before we start. So, why did the programmer quit his job? Because he didn't get a raise. So we have to start with a small review of arrays. Arrays are data structures that can store a fixed size collection of elements of the same type. The elements inside of an array are stored in contiguous memory. This means that each element is directly behind the last one. The first element has the lowest address, while the last element has the highest address. To declare an array, you declare the type, the name, and between the square brackets, the size. So here's an example of declaring a digit array of 10, and it's just 0, 1, 0, 3, 4, 5, 6, 7, 8, 9. So you notice there's a mistake there. So you can get the particular element using the square brackets and the index to put 2 where it should be. And pointers, I'm also going to explain to you. So here's a comic about pointers. So also quick review. Before knowing what pointers are, we have to understand that a variable is stored in a memory location, and the memory location has an address. The address can be accessed using the ampersand operator. So here's an example which also demonstrates how the elements in an array have continuous addresses. So it's just again the digits array, this time with the correct standard of C, and just a loop printing all the addresses. And here you can see that the size of an integer in my machine is of 4 bytes. So, a pointer is a variable which value is the address of another variable. You declare it in the typing the type, then asterisk, and the variable name. So, for example, you appoint a pointer to integer will be an int asterisk IP data. And to assign the address of a variable, we use the ampersand operator, and to access the value of the address stored in the pointer variable, we use the asterisk. So how are arrays and pointers similar? Well, what if I told you that arrays are pointers? Well, not really, but they are very, very similar. How? Well, their notations can be mixed. Here I have a pointer that will use the notation of an array. So I have an array, a character array, which is a string, says hello. And then I use the asterisk to declare a pointer to a character array. You might be wondering why here I'm not using the ampersand, and that will be explained in a couple of slides. So here I'm going to be changing the first element, so not the element at index 1, not the first one, the element at index 1 to A, so that this string says hello. And as you can see, it works. And I'm using the array notation on a pointer. And now here, I'm going to be using a pointer notation on an array. I have the array cword, which has the string hello world. and I'm just going to print it. I'm going to print each character, and I'm going to be using pointer arithmetic to do so, which is pretty cool that this works, right? So this happens because the array name cword is actually a pointer to the first element of the array. So that's why here we didn't need to include the ampersand operator. It's because the keyword, the array name, is actually a pointer to the first element of the array. This is called decaying because the array decays to a pointer. In the C programming languages, the most usages of array are basically the same thing of using a pointer. Of course, there are exceptions. The biggest ones are using the size of. So the size of the array will give you the size of all of the elements that are in the array, while the size of a pointer is always a fixed size depending on your processor. So here I have in the right an array, the same character array, which has 10 elements. So the size of this will be 10, and I'm just passing it as the array name. So it should be used as a pointer. However, it is not. So it's not exactly a pointer. It's still an array. And the array in my computer has a size of 4. Also, you cannot assign to the array name by itself. So you cannot do this with an array, but you can do it with a pointer. And so those are two things that are different, but there's a couple more differences. Arrays automatically allocate memory, while for pointers, the programmer needs to explicitly allocate or also delocate the memory. This means that pointer memory can be resized using realloc, while the memory that's given to an array cannot be resized. So arrays are more static, while pointers can be dynamic. As I mentioned before, the size of the pointer is always fixed, and the size of the array depends on the elements, number of elements, and the type of the elements. And you can get the address of a pointer. However, if you try to get the address of an array using just the array name, it will give you the address of the first element, which is this example here. And so we talk about malloc, another x86 steps with explaining it better. So this is just a little preview, and it just manage all the memory. So this program, what it does is asks for the user for a number of elements, and then just asks him to input each element, and it gives him the sum. So I'm just printing, asking for a number of elements, scanning it and setting it into Imax, which is my variable that tells me what's the maximum number of elements. Then here I have a pointer to integers called IP numbers, which then I tell the malloc to give him the size, the memory size that I need, cast it into a pointer to integer, and I do this by using the int pointer, pass, and then malloc, and then it's just tell malloc the size in bytes of what I need, which is just the multiplication of the maximum number of elements multiplied by the size of an integer. And then here I'm just scanning it and saving it using pointer arithmetic and just doing the addition. So here's an example. This could be 6, 7, 8, 100. I just choose 5, and the sum of my 5 elements plus 15. So, can I have an array of pointers, of strings, of lists? The answer to that question is yes, yes, and yes. How, you say? Well, we can have an array that stores pointers, and then those pointers can point to any other data type. So here's an example of an array of integer pointers, or pointers to integers, and what this does is just copies this array that I have here 1 through 5, and it just copies to the new array of pointers, and it just prints the value. So as you can see, I'm printing the value of the array of pointers, and it copied them correctly. So we asked if we could have an array of strings, and yes, we can have an array of strings. One way to do that is to have a 2D array of strings, in which one of the dimensions is the maximum number of strings that we're going to have. In this case, it's just days of the week. And the other one is the max length of those, which I think is Wednesday. And you just add 1 to make sure it doesn't store any garbage. But that's not really important here. So the important thing is that I'm using arrays to store strings. And as you can see, I can print them just by printing if I don't have to print the characters, I can use these S and just print a string. But there's a better way of doing that with pointers, and that's having a one-dimensional array of pointers to characters. So here I'm defining a one-dimensional array of pointers to characters, and I'm just giving them, initializing it with all the weekday names, and just printing them. And as you can see, it gives me the same result. So that's everything for me. I hope you enjoyed it, and as a token of appreciation, here is a cat. Also, if you want to learn more, here's a couple of useful links, and remember that the Stack Overflow is always a good place to find answers. Thank you for listening, and have a good day.